Hi, everyone. I think we've reached a critical mass to start. I think pretty much everyone has managed to get online now. If you're having any trouble joining or seeing anything, we'll get to technical troubleshooting in just a moment, but you can also shoot me an email right now if you have any questions, and someone will be monitoring that. So thanks everyone for joining us today for this Citizen Science Training webinar. My name is Carla Zubricki, and I'm a project manager at the International Institute for Sustainable Development, and I work for IISD's water program. And I'd like to welcome both our attendees and our guest presenters today. We have teachers from various cities and towns joining us in Manitoba, Saskatchewan, and North Dakota on the line today. In fact, this project is now up to 17 participating schools, which is absolutely fantastic, given that our initial goal was to have 10 participating by September, actually, and we got 17 in June. So we're really happy about it. So thank you to all of you for joining us. We're really very excited to have you all participating. And I'd also like to thank those people who helped us find teachers who were keen on watershed science and in participating in this project, including Kent LeWarren from the South Central Eco Institute. Kent's already introduced many schools in Manitoba, some of you who are participating today, to some great citizen science methods. And we're happy that the approach we've created complements the fantastic work that he's been doing for several years now. Some teachers on the webinar today are also members of Canadian Geographic Education, with whom we're very happy to partner on this project. Last year, they invited me to attend a pilot citizen science workshop they held in Brandon, Manitoba, and that was really where the idea for this larger network of schools started to form, bringing us to today. And I'd also like to acknowledge our guest presenters. You'll be hearing from each of them later in this webinar. In the room with me here at IISD in Winnipeg, I have Tiffany Taylor, coordinator for the Cocoa Raw Precipitation Monitoring Program in Manitoba, and Jeffrey Gunn, project officer and GIS specialist at IISD, who will be talking a bit about safety later in the webinar. And then joining us remotely, we have Katrina Freys from Fort White Alive, who will be telling you about some interesting species in the watershed that you can keep an eye out for. Apparently, I somehow just got muted. Jeff, how long did that cut out for? Okay. Sorry about that, but hopefully you didn't miss too much. I'll just go back a bit and did anyone type something in and say where? Sorry about that, folks. Anyway, just a little bit more about the water program. We work mostly regionally, focused on the Lake Winnipeg watershed, and we're also very fortunate to have the experimental lakes with us now for the last 2 years. I cannot tell anyone lots more about that if you're interested. We're really happy to be partnering with Canadian Geographic Education for this project. I think it was 2 years ago now, they started out a pilot project to explore the idea of citizen science in the Lake Winnipeg watershed with some seed funding from National Geographic Education. And through some workshops that they held, it led to us working together with them to develop this project, which is something that we hope we can grow to even more schools and more provinces and more states. I'd like to provide a bit of a project overview. So this slide gives an idea of what we'll cover in today's webinar. Most of the presentation will be focused on the second bullets, the different existing monitoring programs and websites that we'll be using. So for this project, we decided that rather to reinvent the wheel and create our own monitoring programs and websites, we wanted to build into established and successful programs because the three that are listed on the screen there, CocoRaw, Freshwater Watch, and iNaturalist, are very user-friendly, very education-friendly, and they allow you to upload data easily from the field if you want to use smartphones. You can also easily upload from your computer. And what's important to ISD as a policy institute is that they have already proven that they can provide data that is reliable and that can be used by scientists and governments. So the students will be providing data that is actually used in the real world. We'll focus mostly on phase 1 today, which will involve teachers and students collecting water samples in June and then uploading this to relevant websites. After everyone has finished uploading their data, after June 18th, we'll provide you with some analysis and summary and let you know what the different findings show. And I hope that most of you will also be interested in joining us for phase 2 in September through November or December. This will involve going back to ideally the same sites you monitored in June and to collect more data. And then I'm hoping to create more networking and connecting with other schools through web meetings and discussions. I'd love for students to have the opportunity to present some of their data for us to show them what their data has told us and build the story when we have multiple data points so we can see how the water changes over time, how it varies throughout the watershed, if it's different in spring as opposed to fall, and uncover some really interesting linkages in there, and even compare it to some of the global data that we have. And I'd love to bring in guest speakers, such as one invasive species expert, who I know can speak very well to zebra mussels in the watershed and make it really engaging for students. But for phase 2, I'm also really going to welcome any ideas from teachers about what would be helpful to them, what would be interesting to their students, and what would link well to curricula. We have some project goals in mind that Canadian Geographic and ISD came up with. First and foremost is providing a really positive hands-on experience for the students and to get them excited about science and linking it to the curricula. We also are excited about networking and connecting Canadian-US schools, sharing the data, and then gathering quality data that can be used in the real world by government, scientists, and watershed managers. Just to tell you a little bit more about the Lake Winnipeg watershed, in case you're not as familiar with the scope, I'd like to zoom out a bit from our specific project area we're focusing on right now and consider the whole watershed. So the entire area you see on the screen right now is the Lake Winnipeg watershed. And all of the water in this area is flowing into Lake Winnipeg in Manitoba, which is just an hour or so drives north from Winnipeg. This water represents water flowing from 4 American states and 4 provinces and nearly 1 million square kilometers. And one thing I really like about this project is it gives us the opportunity to collect data on a transboundary basis. So we have one school down in Minot, North Dakota participating, gathering us some water quality data down there, and hopefully we'll build it to more. A lot of monitoring programs you'll find stop at the border. So if it's a US run, for instance, run by the US government, they don't include Canadian data. And if it's a Canadian one, they don't incorporate US data. But part of what we'd like to recognize here is the fact that water doesn't respect borders. So it matters what happens throughout the whole watershed and what the water quality and precipitation and everything is throughout the whole area, because all that water is flowing towards Lake Winnipeg. And there's also some good pressing and driving reasons for why we need to collect more data on the Lake Winnipeg watershed. First of all, there's not enough of it on many of the topics, such as water quality and hydrology and species. In terms of habitat loss, there's quite a few different habitats in the watershed that have had quite a bit of loss. Tallgrass prairie, there's less than 1% left, and that is a significant portion of Manitoba. Wetland loss in the watershed is high, in some places up to 70%. And it helps to prevent or to improve water quality and prevent flooding, among other benefits. There's pollution issues around nutrient loading that I'm sure you've read a fair bit about. Climate change, it's expected that the watershed will experience more severe floods and droughts in the next, in this century. And then endangered species, there's some interesting things that could be explored with this project. For instance, the Saskatchewan portion of the watershed contains critical habitat for endangered whooping cranes. They stop off on some water bodies along their way on their migrations. And there's other ones that we can identify. And a little bit later, Katrina from Fort Wayne Alive will be speaking to different species you can keep an eye out for. But first of all, I'd like to pass things over to Tiffany Taylor, who's the coordinator of CoCoRaH in Manitoba. Now, I'm a big fan of CoCoRaH and have one of their precipitation gauges in my own backyard, as do several of my coworkers. What's great about it is it doesn't take a long time to do, it's simple, but it really provides some powerful and very useful data. As Tiffany will explain a bit more, both Environment Canada and the province of Manitoba regularly access the data from the website and use it for real-world applications. It's also used by governments in the United States, which is where CoCoRaH started out. Now, I know I mailed out the kits last week. I know some of you have confirmed you've had them arrive. It might take a little bit longer for some of you. Please, if you don't get it within the next few days, do email me and let me know, and I can check on its status. So now I'll pass you off to Tiffany, who can tell you more about your new precipitation gauge and how you can use it. Actually, what we'll do first is we're going to play a video. So I'm going to pass control over to Jeff, who's able to play that for me.
I'm going to read this out. So if maybe that'll come up well. Is everybody seeing it? Oh, they can hear me. Can I talk? Okay. Did everybody get a chance to see that and hear that? Okay. All right. So I'm just going to tell you a little bit more about our program in a bit more of an official capacity. You saw from the video that COCORA stands for the Community Collaborative Rain, Hail, and Snow Network. And we are a unique precipitation monitoring network consisting of volunteer weather observers or citizen scientists all across the province who report precipitation data in the form of rain, hail, and snow. By submitting daily precipitation readings onto the COCORA website, you'll be providing flood and drought forecasters with precipitation data they would otherwise not have. Having volunteers on the ground to track local conditions helps fill in the blanks and supplies forecasters with the data necessary to develop a more complete precipitation and snowpack picture. Our program aims to improve an understanding of the distribution of precipitation across the landscape. You will become weather aware, be able to share and compare weather data, yet be helpful at the same time. COCORA is supported by Environment Canada, Farm and Food Care, Weather Innovations Network, Glacier Farm Media, Manitoba Infrastructure and Transportation, Agriculture Canada, Water Security Agency, and many local watershed and water management organizations who also utilize our data. So we know that precipitation is important and can be highly localized. There are large distances in between automated weather stations where little to no reporting or data exists. Given the severity and variable patterns of our weather, there is a need to strengthen the data currently being collected in a very hyperlocal sense all around the province. With a notable trend in the decline of federal weather stations, COCORA helps add to that necessary data. Additionally, the data a volunteer can provide is a complement to the automated weather stations that are already in place. Each day, Environment Canada picks up the data from the COCORA website. This is data that our volunteers submit and is made publicly available for all to see on our interactive map. The data is filtered down to a host of end users, like flood forecasters, who monitor the floodplains in the spring and the summer. It's also being used to measure drought impacts on rural and urban areas. Studying these areas can lead to developing tools or practices to mitigate their effects. COCORA can also help increase awareness of regional and local water events that impact your water supply and can help protect your watershed. It is important to note that accurate data is essential. That said, mistakes happen, and you'll be happy to know that our program has several quality control checks in place to verify the data that comes in, including but not limited to daily monitoring by the National Weather Service and the National Oceanic and Atmospheric Administration in the States. We encourage folks in their respective communities to help us develop the network because Manitoba is a catchment area for all water flowing in from other provinces and the U.S. Therefore, accurate precipitation data from all these regions is truly important. So, folks both urban and rural, young and old, of any age or background are encouraged to join. It's easy and it's fun. So from here, we're going to go to the slideshow on how to get started, just basic training. So everybody can see that? Okay, so you're going to want to go to the Kokora Canada website. The link is listed there for you. So you can click on that and go to the website. I think we're going to just pull that up really quick so you can see it. Okay, so we're on the home page here for Kokora Canada, and as you can see, there are two yellow orangey colored Join Kokora icons on the front page there. So you'll just simply click on those, and that's going to take you right to our application page. So there's an idea there of what the application page looks like. It's pretty basic information: name, address, phone number, email. You have to choose which, or you have to at least mention if you're choosing metric or imperial. And in this case, it's going to ask you, how did you find out about Kokora? We're hoping you can cite the IISD so that we know we can gather you together for anybody that joins as a group, so we can track everybody's data as we go. So you can do that. You can fill in your name either by your school name. So in the example on the slides, you'll see that first name Johnson and last name elementary school. So you can do that like that. So Miami School would be Miami Elementary School, that kind of thing. Or you can simply just use your name first and last and go with the rest. So after you're done all that, you'll just click Submit, and within 24 hours, you're going to receive an email, and it's going to have your personal login information on that. Your username and password will be there after you register, and so you'll use that to log back in and begin submitting data from that point. So, yeah. Okay, so installing your rain gauge and positioning it. So we're going to want to post the gauge in an open area, away from obstructions like building walls, underneath trees or as far away from trees as we can get, sprinklers, animals, or anything that might artificially sort of enhance or decrease the catch that your gauge is going to get. So the best you can find is all we ask. It's a public space. Sometimes it's a little difficult, but if you're rural, it might be better off that way. But if you're in the city, don't worry about it. Just do the best you can to make sure the space is as open as possible. You're going to want to make sure that the post or the structure that the gauge is attached to is about 4 to 5 feet off the ground. And you're also going to want to make sure that it is level, not crooked or anything like that. That will also artificially affect your catch. We're going to ask that you can cut the top of the post mounted so that it slants away from the gauge. It helps reduce splash, so we call that beveling. And you'll see that in the picture there. You're going to see the top of the post there is angled downward. That does help reduce splashing, and it also helps reduce snow falling needlessly into the gauge, which also affects the catch. Inside your containers, you will have an inner and outer cylinder. You're going to have a back plate in there, a packet of screws, and some instructions. Okay, so where to enter your data? So you're going to want to go to back to the Kokora website and click on My Data, which is right. Can't find the mouse. Right about there. It says My Data at the top in the blue. So you just click on that. It's going to prompt you for your username and password at that time. So just punch that in, and you'll be ready to go and start submitting your data. And just from there, just go ahead and start punching it in every 24 hours or as often as you can. Submit is on the top and bottom of the form, and we're going to go and we're going to see that next. Or not next, after this. So when to enter your data? Well, we're asking for daily, but we know that that's not possible, especially with schools. So we just ask for as often as you're able to do. The best time for you guys to submit your reports is before 9:30 a.m. The reason for that is because Environment Canada picks up the data from our site before 9:30 each morning. Any time within a 24-hour period is still fine. Your data still counts, but it doesn't always make it onto the interactive map, and you won't be able to necessarily see your reading for the day if it's after 9:30. But like I said, it still counts. It's all good. But for students who want to kind of go and follow through to the interactive map and see their report, sometimes after 9:30 it doesn't always show. So if that's possible, that'd be great. Okay, so how to enter your data. This is your data report form. It says My Data Entry Daily Precipitation Report Form. So you'll enter the data in the box at the top labeled rain and melted snow to the nearest inch, or in this case, for metric users, millimeter kind of thing. You'll notice that there's an observation date at the top. It's always going to have the current date there. If you're backtracking for a previous day that maybe you missed, you can move that calendar back a day or two or three or whatever and fill in those reports that way. But when you log on each day, it's always going to have the current date there. There'll be a default time that you'll set up when you apply on the application sheet, but it doesn't have to be that. It may default to 8, and you may not take it till 8:30 or 9 kind of thing. So don't worry about that. You can simply change the time there as to when you've gone out to read your gauge, and that'll be fine. And then in the box below that, you're going to see rain and melted snow to the nearest 100th inch. That little box is going to be where you will submit your reading for the day. So there are 3 things that you're going to encounter. One is that you're going to get absolutely no rainfall at all. They're going to go to the gauge and there'll be nothing in that. And that'll be probably be the most common. But in that instance, we don't not report that day. We need to know actually that it didn't rain. And the only way for us to know that for sure is if you enter a 0. So when you go to the gauge and there's nothing in it, come back to the classroom and submit a 0 on the report. That would be great. Second thing you're going to encounter is something called trace. T for trace is what you'd put in that box, so just a capital T instead of a number. So that means a trace amount, and that's when there's just a few droplets on the inside of the gauge. Not enough really to amount to an actual number. There's another circumstance that you would want to report trace, and that would be if somewhere in the middle of the day a rain event occurred, but by the time you went to check your gauge the next morning, it had completely evaporated. We still know that there was a precipitation event that occurred, so we still want to report that, and so that's when we would enter a T for trace as well. And then the third thing, of course, is that we did get a rain event, and it did amount to something, and so you go and you check the inner measurement tube for the number, and then you put that in the box. Something else students can do is use the observation notes there in that bigger box. Students can mention additional weather information like frost or dew, temperature, wind, any number of things that they're noting in their environment. You're free and welcome to put that information there. When Environment Canada and the other agencies go to our website, they are looking at that information as well, so it's very helpful if we can sort of see the extra things that go on. Okay, so how your gauge works. I think I'm going to get you to explain that in a more scientific capacity than I will. So go ahead, Jeff.
All right. If you can hear me? Yep. So this is something that trips a lot of people up. Tiffany mentioned that she's had this question quite a few times, is why is 1 inch on your inner gauge so much bigger than an inch that we know? We know how long an inch is, but what you see on your inner gauge is a 1 inch stretched into probably 6.5 inches. So the reason for that is we use this large funnel on the top, and that collects rain from a wider area than the inner gauge. And that wide area lets us stretch out the single inch to a much larger stretch, so we can be more precise in our reading. Think about if we had just 1 inch in that inner gauge, it would be quite tiny, and seeing the differences between 0.14 of an inch and 0.16 of an inch would be impossible to see with the surface of the water. So when you're reading the gauge, make sure that you know that at the top of it, the value of 1 for inches is just 1 inch. And the similar thing goes for millimeters. And I know, like I'm a scientist here at ISD, but the first couple days I did my readings in the wintertime, I had to think back and say, okay, does that make sense? Did we really get 22 inches of snow this evening? No? Okay. So don't worry about that, but just take a little extra time when you're starting off.
Thank you.
Back to you, Tiffany.
Okay, so we'll move that forward. Okay, so the inner measurement tube or inner cylinder, when full, does hold 1 inch of rain. Converted into metric, you'll see on your inner measurement tubes, for those of you who have them in front of you, it amounts to 25.4 millimeters. The reason it's 25.4 millimeters is because that converts exactly to 1 inch. If the inner cylinder is not full, then you have less than an inch of rain, or less than 25.4 millimeters. If water has collected into the outer cylinder, you have more than an inch of rain, and at that point, you're going to experience overflow. In the case of overflow, students will need to pour out the first inch, or 25.4 millimeters, of rain from the inner cylinder, and then pour in the water from the outer cylinder to measure it. And then you'll just simply add those all together and come up with your total. So the inner and outer cylinders combined can hold a little over 11 inches of rain in total. It's 1 inch plus 10 inches. And in metric, that is 25.4 millimeters capture in the inner cylinder and 254 millimeters capture for the outer cylinder, for a combined total of 279.4 millimeters. So if that ever does get full, we've had one heck of a rain and a lot of problems. Okay, so metric users, if you're looking at your inner tube right now, some folks have some questions about how to make sense of it, how to read it. When reading in metric, increments are by 0.2. So 0.2 millimeters.
Oh, there we go. We're just fixing that. 1 second.
Can everyone hear me? Okay. So we're just going to go back to the start of the slide. That one. Okay. So I'm just going to go over this again just in case anybody didn't hear it. When reading in metric, the increments are by 0.2 millimeters. Each incremental dash on the inner measurement tube is counted by 0.2 millimeters. A common error that folks make when reading it wrong is reporting each dash on the tube as a millimeter. That's not correct. It is 0.2 for each dash. So you can see from the example on the pictures, I drew a little blue line there so you can see. There is a longer black dash at the very bottom of the image, and the first to the left there. That signifies 0 or a base count. The next picture, if you can take a look at it and see the blue line, you'll see that it's 0.8. So if we were to count that, there's the black dash that means 0, and then there's 0.2, 0.4, 0.6, and where the blue line is, 0.8. And in the next one, the third one, you'll see the same thing. You see the black dash, 0.2, 0.4, 0.6, 0.8, and 1. And that's where the blue dash is there that I marked on the screen. And then the next one, I did a 4.4, so you can see going up 2 millimeters, then there's 3 where it's not marked, then there's 4 where it is marked, 4.2, 4.4. So hopefully that makes sense to everyone. And if you have any questions about that, just please feel free to contact me if you're unsure about the first day's reading kind of thing. I can help you out with that. Okay, so viewing your report on the COCORA map. After you submit your report for the day, you're going to see an option at the top of the copy of the report to view your data on the interactive map. So what we encourage folks to do is go and take a look at what you've reported, along with seeing what everyone else has reported for the day. You can also go onto that map and look at other days as well and do some comparisons. So at the top of the page, you can click on Maps as well. If you happen to miss the part where it prompts you to go to the interactive map, at the top of the page, you're going to see Maps in the blue area. So you just click on Maps, and then you click on the Canada icon, which you can see right here. So you click on Canada, and it'll take you to the Canadian map, and then all the data will be there for the day. Okay, so when you get to the interactive map, you'll be able to zoom in and zoom out for a closer look at what people have been reporting, as well as your own report. You can also click on each dot, and that will call up the station name and number, location of the person reporting, and what they've reported. And if you're curious as to more details, you can actually click there where it says go to report details, and you can take a look and see if they've actually made mention of a few more things. We had a fellow a day or two ago do his report, but then also submit that he had experienced hail and various different things like that. So there's always sometimes, well, there's usually information additional when you go to check out the detailed report. So you can see from the map that there are dots everywhere, and that signifies the folks who have reported for the day. And again, you can sort of get a kind of a bird's eye view of the pattern of precipitation for the day and where it fell heaviest. On the right-hand side of the screen, you'll also see a scale. It's like a sliding scale. And this sort of indicates, for that 24-hour period, a sliding scale of amounts, and it's color-coded so that you can actually sort of look at the amounts for that day from highest to lowest. Okay, so editing your report. Sometimes folks make a mistake, or they want to add something to their reports, so they want to go back and take a look at it. So what you do is on your report page, you can look to the column on the left-hand side in blue, and there it will say edit or list/edit my reports. I'm just going to show you, it's right here, list/edit my reports. So you can click on it and you're taken to a list of all your reports, which you'll see in the second picture here. So the list of everything that you've reported will show up on the page, and you simply need to go to the right-hand side of the screen and click on the icon. It looks like a little pencil and eraser. So you just click on it and your report will come up. You can make the changes you need or additions that you want, and then just resubmit once it's been revised. Do we have time for me to go into that, or should I just sort of mention? Okay, so if you haven't measured your rainfall in several days, and it needs to be entered as a multi-day report. Or for some schools, they simply opt out of reporting when the weekends happen. So it's kind of, it'll be up to you guys, I suppose, what works best for you. We encourage the use of the multi-day report form when you've skipped a few days for whatever reason. But you know, if it doesn't work out, just simply opt out of it. On the menu at the left-hand side of the My Data page, you can choose the multi-day accumulation report. It's highlighted there in red. And the first day you enter should be the one day after your last report. And also enter the day and time that you read the gauge at the end of the accumulation period. There's an example there. I'll let you guys read on your own as to how that kind of works, but the reports are set up in a 24-hour period, so it's important to not overlap days, which is sometimes what happens there. This is just an example of other reports that can be run. You can run monthly zeros. It can take you on a quick look to see if you're looking for drought information or that kind of thing, how many zeros you reported in a month and stuff. So if you see on the left-hand side there, there's all kinds of reports that you can sort of click on and take a deeper look into. Another thing you can do is view the data. So at the top of your page, you can click View Data, or follow this link, which is you can just click on after you've been submitting some reports. Or if you want to take a look at other stations' reports, you can also do that. You can run a whole host of reports there, and you can take a look at precipitation data, daily comments, and the observation notes. You can look for significant weather reports, hail reports, drought impact reports, evapotranspiration reports, although there aren't that many. There's all kinds of things you can do there. You can run by station, you can run by province, any other number of things you can do. We can also run a group data report form as well. So we'll have you tagged as a group, which is probably be a -ISD tag on everybody's station identification number. And so then we can also run some bulk data reports that way as well to see what you guys as a group are submitting in the form of precipitation and such. Okay, so if you're looking for contact outside of Manitoba, we have Miles in Ontario, his number's there. Gary Sibley in Saskatchewan. You'll talk to me for anything to do with what happens here in Manitoba for signups. And then the other provinces, Angie Knowles out of Ontario, will take information for anybody signing up in BC or Alberta or other places like that. So that's it for me. Thank you.
Thanks so much, Tiffany. That was really helpful. And we didn't even get into snow yet, the snow measurements, which is what Jeff and I started out with. It's actually quite easy as well. You just have to melt the snow first, bring it inside, and then do your measurement. And for those of you who are interested in trying that out, we can organize another webinar in September to do that, or well, not September, maybe November, once the snow might come. The next program that we're going to be using that I'd like to describe a bit is Freshwater Watch, and that's where you'll be inputting all of your water quality measurements. So Freshwater Watch is run by the Earthwatch Institute of the UK. It's global in scale, so those orange dots you see on the screen represent where some of the different water quality measurements are being taken for this project, you'll notice that the middle of Canada is pretty sparse. So we're going to change that. We'll be measuring for phosphates, nitrates, and turbidity. And what turbidity is just how cloudy the water is. So for instance, at the Red River here in Winnipeg, it has really high turbidity because there's a lot of sediments in them. Hence it's called the Red River. When you record your data, you'll also include other useful observations, such as what the land use is, any potential pollution sources in the area, the speed of the flow, and things like that. And we'll also be recording temperature and pH using this website. And already this organization has been used by scientists and governments in various ways. For instance, they use the phosphate and nitrate information, or they can use it, to predict where algal blooms might happen. And there was one academic paper that came out showing that it could accurately predict algal blooms. And another interesting example is the use of it to identify when there was a problem. It was sort of an early detection. The citizen scientists noticed that the nitrates had spiked off the chart in one Southeast Asian city, and the citizen scientists who were running the program alerted the municipal government, which looked into it, and there was a problem, and they addressed the issue, and the measurements went back to normal. Now, the exact location or even what the issue was can't be shared due to legal reasons. I have no idea what it was, but it's a really interesting case study that shows how citizen monitoring can be valuable, because otherwise, who knows when that problem would have been found. So next, Freshwater Watch has made it really easy to explain their program because they have a really handy training video. So we're going to get into that in a minute. I'm going to have Jeff run the video for you. Before we do that, for those of you who have your kits, I'll just let you know which items we're going to be talking about. It came in a nicely packaged container in a cylinder. You'll have had some rubber gloves, some silvery packages that contain your phosphate testing tubes and your nitrate testing tubes, a little tiny sample cup. Be careful with that, don't lose it. I provided a plastic bag for you to store it in, and then also your thermometer and pH paper. And the one thing you'll need to add, and we didn't send one along because it's pretty easy to find, you need some kind of collection container when you went out. So you could use a clean milk jug that you then cut open and can scoop up water. When I went out before, I used some Tupperware. So that's one thing you'll need to add. And without any further ado, I'm going to get Jeff to share. Let me just pass control over to him. And he's going to share their video. Okay, go ahead.
when the tube is full. Record this as less than 14 on your data sheet. You can send your findings from your testing location or save them to send when you have an internet connection. You can also edit your uploaded data through your Freshwater Watch profile if you need to. If you filled in a data sheet, be sure to upload your data next time you're online. And that's it. You've collected your first data set. You should carry out Freshwater Watch and minimum
Well, can everyone hear me? Yep, okay. They do a really good job of explaining it, as Tiffany was just saying to me, oh, they make it look so simple. But you know what, Jeff and I went out a week or two ago and tried it on the Red River, and it really is manageable, but you really also see the results when those water quality tubes change color. So this is a really great addition to our kit, and we're really excited about it. And you can do the recording of the data from the field using your smartphone. I sent some data sheets along in your kit, so you can those will start you off, and you can write on those and then enter them on your computer later. And you'll also be able to print off more data sheets once you have an account with Freshwater Watch. And one more thing that they didn't cover in the video that we've added on is we'd like you to also measure pH, so the acidity or alkalinity of the water, and temperature. Those are pretty straightforward. There's instructions I printed off and put in your kit. pH, you just dip it in the water, and then the paper turns color. And for temperature, the only thing to note is for those of you who got the metal thermometer, I had to get some additional thermometers because we'd gone above our 10 planned schools, and I had to find some locally. You have to put that in the water for about 2 minutes because it takes a little while to actually register the temperature fully. And I would recommend you collect the sample, put it in the glass, and then do the measurement right away. Don't leave it sitting out in the sun for half an hour because then it could heat up quite a bit if it's a warm day and you might get an inaccurate reading. And with that, I think we're going to move on to species, and I'm going to pass control of the, or I'm going to, pass control over to, oh no, never mind, I've actually incorporated her slides. Okay, I'm going to have Katrina from Fort White Alive do a presentation. I'm just going to share my screen here so you can all see the slides. Katrina is the education coordinator at Fort White Alive, and let me just bring this up. And Fort White is an environmental education and research center in Winnipeg. It's a great place to go and learn about different species, from migrating birds that visit their feeders in wetlands to the buffalo herd that it has on site. So Katrina's here today to tell us about interesting, endangered, and invasive species you might encounter when you're doing citizen science. So I'd like to invite Katrina to go through some of her top species for us to look out for.
Hi, can you all hear me?
Yep.
Yeah, okay, fantastic. So I just put together a short slideshow with 10 species that might be interesting. They may be invasive ones that you'd want to watch out for. or they might be ones that are more rare or endangered. So the first one that I have up here are, of course, zebra mussels. They've been in the news quite a bit lately. They haven't been found in the Assiniboine River watershed yet, but they're in the Red River watershed. They're found in Lake Winnipeg now. They're moving into new areas. So they're interesting because they're a very serious invader. They cause huge changes in the aquatic ecosystem. They filter feed out important organisms that are sitting there in the lake and change the food web. They also are an economic issue because they will cling on to hard surfaces and clog up hydro dam intakes. And they also, which was a new thing that I learned recently, is that they increase the concentrations of contaminants in the food chain because they concentrate the food that they filter feed, and they drop that out into the sediments, which then gets incorporated into the food chain. So you can take a look at them to ID them. They're striped. They're quite small. They don't get very big. So there's some pictures there of what they look like. And one thing to watch out for with them is that they'll travel to new areas on watercraft that aren't completely dried or cleaned off. So that's the main way that they're getting around into new places. So the next slide just shows a picture of them attached to a surface. So you can see kind of what their size is like. They're very small, but they're very abundant. Okay, so next slide is our plant invader that I have on the list here, which is called purple leaf strife. It moves into lake and river areas and grows along the shoreline. It's an interesting, and wetlands and ditches as well. It's an invasive plant, so it grows and it outcompetes native plants that would normally grow along those shorelines. And so in doing that, it causes damage to the wildlife habitat that occurs there. The plant's 3 to 6 feet tall, has lots of stalks, square stem. The leaves are shaped like little swords, so lance-shaped leaves, and the flowers are pinkish purple. This plant came in from Europe. It came in with a gardening trait, and there are varieties that were produced even here in Manitoba that were used in the gardening trait. But it also came in unintentionally with livestock, and it produces lots of seeds, so it moves into new areas very quickly as the seeds move along, transported by the water. So if you do find this plant, you can actually remove it on your own. If you find it while it's flowering, that's the best time to remove it, because then you won't be spreading any seeds around as you're removing the plant. It is really important to get all the roots out though. So if you can do that, you can get everything into a garbage bag, dry it out, and bag it up, and you can send it to the landfill. But another thing important about this plant is to report it if you see it in an area or an area where you are. There are a lot of local organizations in different provinces that take the reports on where it's located. So the Invasive Species Council of Manitoba is involved in that in Manitoba, and the Purple Leaf Strife project. You can move on to the next one. Okay, so this is our beaver, very important animal to Canada, not endangered or threatened in any way, not invasive. They're found in rivers, lakes, wetlands. They're actually one of the only animals other than humans that manufacture their own habitat. They'll dam up a creek so that they can create a pond, which is what they prefer to live in. They're interesting because they are an animal that historically fueled the fur trade, which had a greater impact on Canadian history than any other animal or plant species that we have here. They also were close to extinction by the mid-1800s due to the fur trade, and now they've recovered to more healthy levels. Most people know what a beaver looks like. They're quite large. They weigh up to 35 kilos. They can measure over a meter from their nose up to their tail. They're Canada's largest rodent. And interesting facts about them: they use their tail to steer, to move as a propeller. They'll use it to defend themselves by slapping the water, defend their communicate to their other beavers in their group. And they also have to constantly chew on things, otherwise their teeth will grow too long. And they can chew underwater without opening their mouth. So a lot of interesting facts about the beaver. Okay, go on to the next one. So the next one we have here is our monarch butterfly. The monarch butterfly is talked about quite a lot in the news as well, so it's a popular one. Their range extends north to the Interlake region of Manitoba, west through Saskatchewan and Alberta. The host plant for the caterpillar, which is called milkweed, which is pictured there, that grows along the roadsides and ditches. It'll grow, different species of milkweed will grow in grasslands and swamps and other areas. Monarchs are interesting because the eastern monarch population, which is the one that we see around here in the summer, they've experienced a significant drop in their population. The lowest recorded overwintering numbers in Mexico occurred between 2012 and 2015. They had a bit of a rebound in the last year, but it's still 30% lower than the long-term average population. Their population is impacted by loss of breeding habitat. In farming practices, the removal of all weeds is impacting the amount of milkweed that's available along their migration route. Climate change affects them as well, and deforestation where they live in Mexico. So they're a big charismatic butterfly, orange and black. We look for white dot markings around the edges of their wings. There's a butterfly that's a mimic. It looks kind of like a monarch. It's called a viceroy. And the viceroy has an extra black stripe that runs along the rear edge of its hind wing. So that's in the picture there. So you might see one of those, which is also an interesting species to note, but it is not a monarch. And of course, the caterpillars are black, white, and yellow with long filaments that look like antennae on both their back end and their front end. And an interesting fact is that when they come back to Canada from their overwintering grounds in Mexico, monarch butterfly that you see here will be the great grandchild of the original monarch that was overwintering. They go through about 3 generations before they get back to Manitoba. You can go to the next one. Okay, the leopard frog, the northern leopard frog. Beautiful big frog found in ponds, marshes, lake shores, and even in urban areas they can be around. They just need a water body that has a lot of plant life underneath the water. Frogs are interesting in general because they can indicate habitat health. They depend on the water for their life cycle, and they absorb oxygen, and they can absorb other substances, including pollutants, through their skin. In the 1970s, leopard frog populations crashed, and many populations have still not recovered fully, so they're a good one to look for in your area. They're about 11 centimeters long. They can be green all the way to brown for their main body color, but they all have large dark spots all over their back, sides, and legs. And tadpoles are really big, as you can see in that picture there. If you're looking for them in spring, you'll hear the call of the male leopard frog, and it sounds like someone who is snoring really loudly. So it's a good thing to listen for with them. And they breed between March and June each year. Let's switch to the next one. Okay, going through our different groups of animals here, we're on to the reptiles, and we have a western painted turtle. You find these along rivers, marshes, ponds. They're a beautiful turtle. And they're the most widespread type of turtle in North America. Their population is reduced by habitat loss and being killed on roads, but they are quite able to live near humans, so they are our most abundant turtle. And a turtle can live to be more than 55 years old in the wild, so they're quite long-lived. When you see them, you'll see they're dark on top, but when you look underneath, there's this beautiful painted colors of yellow, sometimes red, with dark markings. Their skin is dark olive with yellow stripes, and they can grow up to 25 centimeters long, so they can get fairly big in their older age. Another turtle that is sometimes seen is called a red-eared slider. They're pets. They are not native to this part of North America, and but they're sometimes released by people who don't want their pet anymore, and they'll let them go into the local pond. If you see a red ear patch on a that is a characteristic of a red-eared slider, so something to watch out for. They're interesting because of the way they can survive the winter underneath the mud or in the soil or sand by cooling their body temperature down to below 6 degrees Celsius and somehow, and using their adaptations to not freeze solid. They can keep their body from turning into ice. Okay, we move on to the next one. Okay, the next one we have here is the wood duck. A special species to Fort White because we have a wood duck watcher program at Fort White where people can have a wood duck box installed if they have riverbank property and are a member of Fort White, and that box gets maintained each spring by volunteers. So they're found along rivers, creeks, and swamps, and they are a duck that will normally nest in a hollow tree trunk, so they're cavity nesting ducks. They use holes created by woodpeckers in the trees. They were overhunted, and their populations were quite low. Around the 1940s, people were really concerned about the wood duck populations. So there were various programs that popped up, including creating the wood duck nest box program. And installing nest boxes along the Assiniboine and Red Rivers in Winnipeg has really helped to rebuild the population of these beautiful ducks. So if you look at them, the male is the one on top there that's much more colorful. They've got a crested head, red chest, darker body, lots of white markings. They just look like they were painted. The females are also quite beautiful. They're more brown, but they have a lot of iridescent blue patches on their wings, and they have a white marking around their eye. And wood duck ducklings do come out of their nest up in the tree, and they'll jump up to 15 meters out of the tree and land on the ground and be just fine. So that's another interesting thing about them. Okay, the next one. That will be our lady slippers. So there are pictures on this slide of 4 different types of lady slippers that can be found in Manitoba. The one on the top left, the small white lady slipper, is an endangered species. It's classified as endangered nationally, so it is a very, very rare one to find. But the yellow lady slipper can be found fairly often, as well as the showy. And the moccasin flower, if you're out in the boreal forest, would be another one you would find. They can be found in roadside ditches. So that's another place that you can keep an eye open for lady slippers, other than meadows, forests, other places like that. They take many years to establish in a space, more than 5 years for a seed to germinate and grow and produce a new plant with a flower. So they are a flower that you'd want to definitely not pick and maintain in the spot where they are if possible. The small lady slipper is only found in unbroken prairie and wet meadows in the Tallgrass Prairie Preserve and some other places, including small population near Brandon. They take up to 12 years to reach maturity as a lady slipper, so they're very slow growing. So the one thing just to say about lady slippers, definitely something to notice and record, but don't try moving any of them unless it is certain that their habitat is being destroyed for some sort of development. They just don't take well to transplanting into new areas. So one more, I think, and then we're done, which is our charismatic grass of the tallgrass prairie, the big blue stem, which happens to be Manitoba's provincial grass emblem. You'll find these tall grasses growing in either native or restored tall grass prairie and in ditches throughout the prairie regions. They do like years when there's a lot of moisture, so we're on our way right now, in this month anyways, this spring. tallgrass prairie, its extent has decreased to well below 1% of its original extent, but this species can be found outside of those protected areas. To identify this grass, it's called turkey foot. If you look at the seed head, it's got a shape kind of like a bird's foot. They'll find it in large clumps. It can get about 1.5 meters tall. The leaves are kind of blue-green. Sometimes they have a purple tip, and the stems also are green, and they'll turn purple, especially into the fall. And an interesting thing about this plant is that the roots are so dense and thick, it formed very strong sod, which was useful in construction of sod houses that were built by the first European settlers on the prairies. So that's another interesting thing about that plant. So those are my top 10.
Thanks, Katrina. It'll be really interesting to see whether or not any of our citizen scientists find some of those species. So what we're going to do next is I want to show you quickly how you're going to be entering your readings onto iNaturalist. So I'm just going to share my screen again. And stop sharing the PowerPoint. And I'm just going to walk through quickly. I'm mindful of the time, so I don't want to spend too much time on this. It's pretty straightforward. You'll just create an account on iNaturalist. I've created a project for us, so I've already done a few observations. You should see on your screen the outline of the Lake Winnipeg Watershed. This is where we're going to be recording our observations, and I'm just going to show you how you can do one. So I'm going to click on Add Observations to this project, because this is a specific project we have. It wants me to sign in again. So I was at the cabin on the weekend, and there were quite a few interesting species out there, a lot of birds. The one I think I'd like to record that I haven't done yet is a chipmunk that I saw. So if you start just entering the name here, normally it just pops up. So I know that this is the one I want, but if I don't know what I actually saw, I could upload a photo and click on ID, please. And if you're not sure what you saw, you can guess what it is, and then click on ID, please. And there's actually people who use this site who are specialists, and they'll go through the photos and help you identify what you've seen. So if you found something, you really want to find out what it is, but you're not even sure, well, can I upload this? I don't know what to call it. Don't despair. Upload it anyway. Just take a photo. Photos can be really helpful in iNaturalist to confirm that your observation was correct, and also to get identification. So you can do that. I'm not going to this time because I know it was a chipmunk. You can check off whether it was captive or cultivated. The chipmunk was not, but let's say you were at the zoo. You can record what you see there, though normally iNaturalist is more for what you observe in the wild. But if you want to report something that was captive or cultivated plants, do check this off, because otherwise, let's say you're at the zoo and you record that you saw a Siberian tiger, that's a little bit alarming for a naturalist to think that suddenly there are Siberian tigers on the prairies of Manitoba. So please just be careful of that. But then you say when you saw it. So I was there on Saturday. And then where was I? It's pretty good at recognizing where the location is. So I'm just going to search this and see. Oh, no, that's not it. Oh, yeah. Sometimes it's good to specify where you are. So there we go. So that's my location, and you can add a description if you want. So I'm doing that there. I can add photos. So I added a photo to my computer. I'm gonna go to my desktop. Just add that in. I took my photo with my camera, actually, like not on my phone, an actual camera. Because I'm kind of old-fashioned that way. I haven't yet got a good smartphone to use, but they are quite handy to have if you're out in the field. You can add tags if you want, just describing, you know, Manitoba, chipmunk. You can add other descriptive tags, cute or something like that. So this will just make your observation easier to find, and then, yeah, I think you can add sounds if you recorded a sound. That's also a possibility. And then you can also, if you're uploading these to Flickr, Picasa, or Facebook, you can also link to that. And then that's a basic observation, so you can save the observation, and there we have it. Photo didn't actually show up, but I think they're still just processing it. But anyway, that's all there is to adding an observation. I'm going to send an email with a few more instructions, but using iNaturalist is pretty straightforward, and it's really neat to see what other species are also being observed around you. So now I'm going to pass control of the presentation over to Jeff, and he's going to tell you a little bit about safety, because we want to make sure you keep you and your students safe when you're out in the watershed doing data collection. So take it away, Jeff.
Thanks, Carla. I'll just show my screen here. All right, so we'll just talk a little bit about safety, and that will include the pre-sampling, getting to the water, moving water hazards, rope, line, safety, and we'll maybe briefly touch on equipment. So the first thing I want to say is that sometimes we get eye rolls about safety. I've been doing this for field science for probably 8 or 9 years. Oops, there we go. And, you know, you do get lots of eye rolls. Every activity has inherent hazards, we know. You know, crossing the street can be hazardous, but in field science especially, we find that taking a moment to think about hazards and risk is time well spent. And field research as a whole depends on culture of safety. Every time there's an incident, which is becoming much less rare than it used to be, that inhibits our ability to collect research and good solid data repeatedly. I've heard it said that no scientist is very good if he or she only collects one data point. So we always want to get back safely and have a good time while being out there. Now, I've, of course, added a disclaimer because I know the environment, especially facing you teachers, that this is a supplement to your school's administration policies. From the research we've done, it's shown that physical education in Manitoba are a good resource to talk to. In Saskatchewan, there's Sask Outdoors, which is the Saskatchewan Environmental Outdoor Education Association, and they have an enormous amount of data on getting kids outside. So moving on, we'll just talk about what we would think about before sampling. That would include a toolbox chat. I learned this concept from a safety engineer while I was on the Coast Guard ship Amundsen. And this has become standard practice from everyone from the oil industry to research scientists to natural resources, resource officers. It's every time you do something that could have even the slightest bit of risk, you think just to yourself and even with the group you have, you sit around and say, what hazards will we encounter? What safety equipment do we have? What could go wrong? Are we prepared for this? Who is responsible for what? And to tell everyone in the group, from the supervisor to every single member, to leave the ego behind, to take criticism, to understand that everyone's looking out for each other. I feel like this would be very valuable for students as well, to start getting this into their consciousness before you do anything, just to have a nice open discussion about what's happening. As you reach the site and start to look around, you just do a scene survey as well. You wonder, is this safe? Can we reach the water? Is this a good place to sample, or is it somewhere else a better option? And it's worthwhile to get everyone into that conversation and let everyone know what goes into thoughts about this, and to give everyone give everyone their own voice. And it does sound kind of cheesy, and you heard that before, and there's always a bit of muttering, but I found it's really helpful. And we think about safety, but then we also think, did we forget our watch? Did we forget, you know, a piece of sampling equipment? And it saved a ton of time. So here we are as we did our first sampling site. When we were evaluating how to get to the water, we were pretty lucky here in Winnipeg. We have a river walk and some nice trails that go right by the river. The best place to sample from, of course, are docks and engineered embankments, like we are here. It's very stable. It's concrete. We're at no risk for anything to fall into the water. It's very stable. It's very wide open, and we have places to do our research. Managed trails are probably the next best. I'm thinking kind of muddy or gravel trails that go very close to the water. You can see everything that you're looking around. You can see a clear path down to the water, and it looks safe and stable. Things you'll find on many rivers in the prairies are animal paths, slumps, and cut banks. These are marginal. Take extra care going down them, especially animal paths that are used by deer can be very steep and slippery. They have some interesting shaped legs that can get them up and down that, I don't know, I've slid down a few in my time. We don't want to end up wet at all. Cut banks are something to be very concerned about because on the outer meanders of rivers, especially on the prairies, the river can actually cut into the bottom of the bank, and if you lean over the edge, it might not support your weight, and you could go for an unintended swim, and that's what we want to avoid here. So hazards related to moving water are different than what we encounter in lakes and ponds. It's a much more hazardous environment just because the force of water is orders of magnitude greater than the force of air that we experience as wind. Even in summer, the water can be very cold, and that cold can have some inhibiting effects on you. It's somewhere you don't want to go into unplanned, as we can all imagine. Generally, we say it's good to avoid stepping in the water at all. Use techniques and equipment to avoid it. That includes ropes or poles. That way, we're not putting ourselves at a risk of we're putting some distance between us and the water. And in currents, of course, it can be harder to maintain stability. Now, some of you might be inclined to use hip waders, and that's kind of up to you. I would say if you do use hip waders, use a life jacket, and always have a plan to ditch the waders. So wear a life jacket with your hip wader straps above it if you are going to do that, because there are incidents where people were in the water with hip waders, they get pushed over by the current, and it gets much harder to swim that way. So be careful with that. So in my time working on Coast Guard ships, people are very concerned about ropes and lines. There's some good hygiene, I suppose you could say, about using ropes. Anything you put into the water by rope has a risk of being pulled off by a sudden current or a change in the flow. This is especially apparent in rivers where the current can differ across the fetch of a river. So it's good practice to attach one end to your sampling device. In the picture here, we have a couple of bottles, and the other end to something secure like a strong tree. That said, assume that the rope will be tugged hard when you're using it. Keep everyone upstream of the rope if possible. That way, if the line gets snagged, it just goes downstream and everyone's okay and you can pull it up at your leisure. And this is something that if you're ever near a sailor or anyone who cares about rope, is never step on the rope. And this is mostly to maintain the integrity of the rope. Ropes fray fairly easily. But it's also bad practice because if that rope suddenly goes taut, you can flip over or lose your footing, and we want to avoid that at all possible. So that was just a very brief instruction. Here's a couple of good places. Cold Water Boot Camp talks about what cold water can do to a person. It's a very interesting resource. There's also quite a few water quality places online, and we will provide these and other resources for you if you have any safety questions. If you have any questions, if you're out in the field or if you come back and have an issue, please contact me directly at ggun@isd.ca. I'm happy to help out, and we have quite a few resources available here and with the experimental lakes area.
Thanks, Jeff. And Jeff actually, he spent several years up in the Canadian Arctic and managed to keep himself safe up there. He was up in Greenland, the Beaufort Sea. In fact, he spent some time researching the Hudson's Bay, which is where the water in the Lake Winnipeg watershed ultimately goes. So he has a fair bit of experience in the field, and I appreciate the guidance that you've just given us. And we're almost done our presentations. I know this has been it's a little bit over time, but I just have 1 or 2 more slides to go through and a few next steps, and then we'll let you go for the night. We're not too much over time, so that's good. We've done iNaturalist, how to add your data, Jeff. Okay, so next steps. So we have to get you logged in on the different websites. So you need to create a CocoRaw account. Tiffany can assist you. In fact, I think she can actually, if she has your email address, she can actually add you up. Yeah, she's nodding her head. So I'm going to send each of you an email tomorrow, and I'll ask you to indicate which you would prefer. And for CocoRaw, you will also need to install your rain gauge. We would recommend you get help from your school custodian to do so. And if you have any questions, you can also help us. As Tiffany, I think, might have mentioned earlier, that's one of the biggest barriers for CocoRaw is just getting it set up. But it's so easy to take the readings, and it's not really that hard to set up either. And school custodians can be very helpful in that way. Tiffany also mentioned that she does classroom presentations if you would like any additional information for your students or would like to share it with any colleagues. And I'm going to be sending the slideshow that she shared with links so you can review the info, because I know that everything we've gone through, it's come by pretty quickly. And she welcomes you to call her at any time, and she does respond very quickly. I've experienced that. So. I would also like you to create a Freshwater Watch account, and to do that, I'll send you your individualized link that Freshwater Watch generates. Once you've joined, you'll just have to pass a quiz. It's based on the video that we watched. It's a fairly simple quiz. It's 10 questions. They just want to ensure you understand the basics, and once you pass the quiz, you can start entering your data. So you'll probably have to enter that data yourself rather than have the students do it, because we can only have that one account on there. And then you'll also create an iNaturalist account. I'll send an email tomorrow explaining how you can join all of these and what you should do next. So on iNaturalist, you'll start an account, and then you'll join the project. And I think right after that, you can start collecting data. I'd love if you let us know when you're going out with your class. Depending on our availability here at ISD, ELA, and even on Tiffany's availability, we might be able to join you to provide some assistance and interpretation for students if that's something you would like. It'll be a little bit harder for those of you that are far away, but we do have contacts in those areas too, so it might be possible. So if you like, please do let us know when you're going out. We're asking you to, if possible, please try to collect some data before June 18th. Enter the data online on these websites, and then we'll do some analysis and create a bit of a report for you before the end of the school year. So you can share that with students, and they can see how their data compares to that of other students, what it tells us, and I'm quite convinced we're going to have some really interesting findings. If you have any questions at any time, please let us know. I'm available by by email or phone. So I put up my email address there, my office number, and my cell number. So feel free to just call me up from the field as you're doing some data collection if you have any questions. Jeff had his email up earlier. Tiffany welcomes your questions, and I think that's pretty much all I have to mention now. And with that, we're only a little bit over time. I would love to welcome any questions that you might have. And you can try unmuting your computer if you have a question. The alternative is to just type the question into the chat box, which we're now monitoring, and then we can read it out from there. But if you feel brave, feel free to unmute yourselves and ask a question. Jeff, do you see any questions? Oh, someone typed something in Q&A. No, that was just an old comment. You don't see any? Oh. Okay, it looks like folks are messaging me privately saying that they understood everything and they'll be in touch. So if you do have any questions afterwards, if anything occurs to you, please feel free to email us. Get in touch, and we're looking forward to working with all of you. I'm really excited to be collecting this data. So thanks. And I'll send the webinar and some emails around tomorrow to give you some next steps. Have a great evening, everyone. Thanks for joining us.
Have a good one.